Hello children, so I am back with my video on the chapter electricity for class 10. So what is electricity? We know that electricity is a form of energy which will help us to do some kind of work. And this form of energy, which we call electricity, it is nothing but composed of charges. So when we are talking about electricity flowing through a wire, we know wires are made up of atoms of a particular metal, and when we say that electricity is composed of charges, we actually mean the electrons which will move through the conductor and will help in carrying the current. So if those charges are not in motion, then we call it static electricity. If the charges are moving through the conductor, then we call it current electricity. So in this chapter we will be basically dealing with current electricity. So first we need to define what is a charge. So it is defining a charge is quite complex. So what we do, we simplify the definition by defining charge with the help of one of its properties. So what is that? So charge can be defined as the physical property of any particle, by virtue of which it can either attract or repel another particle. So if we have one charge, so that charge will either attract another charge or will repel another charge. So if the charges are like charges, they will repel each other. If the charges are unlike charges, they will attract each other. So we know that electrical charge is associated with nothing but charge of electron, and charge of one electron, which is represented by letter small e, it is 1.6 into 10 to the power minus 19 coulomb. So the SI unit of charge is represented or is known as coulomb, represented by letter capital C. So now whenever we get any SI unit, we always have to define that SI unit. So suppose defining SI unit means defining 1 coulomb. So to define 1 coulomb, so we know that if 1 coulomb has to be the total charge, so it will be charge of 1 electron into total number of electrons. So because this is the total charge, so total charge will be what? Charge of 1 electron, because charges or the total charge is made up of what? Electrons. So it will be charge of 1 electron into how many electrons are there. So going by this form, we can frame the formula that total charge capital Q is equal to N means number of electron, into E is the charge of 1 electron. So we put the value. So total charge we are going to define. What is the total charge we are going to define? That is 1 coulomb. So I have written 1 here. So we'll find out N. So number of electrons is N, and charge of 1 electron 1.6 into 10 to the power minus 19. Now if we shift it, keeping N here, we bring this 1.6 into 10 to the power minus 19 below. So 1 by 1.6, this gets a value of 0.625 into this goes up. So it becomes 10 to the power 19 from 10 to the power minus 19. So now we shift the decimal here one place. So 0.625 becomes 6.25. So here one place decimal place is increasing, and here one place decimal will decrease. So it will become 6.25 into 10 to the power 18 electrons. So now we can write it in a statement form that we can define 1 coulomb of charge. So when we say that the total charge is 1 coulomb, when it is a cumulative charge or a total charge of how many electrons? 6.25 into 10 to the power 18 electrons. So if your total number of electrons is 6.25 into 10 to the power 18, then their total charge is defined as 1 coulomb. So that was about charge. Next we go to the next term, which is electric current. So now when we are talking about electric current, we can draw a very nice analogy with that of speed. So what was speed that we got in class 9? It is the distance traveled by a body in a given time interval. Similarly, electric current means something which is in motion, something which is flowing. So suppose there is a conductor and there is a cross section of the conductor. So through a given cross section of a conductor, how much charge is flowing? Q in a given time interval. That is known as current. So we can define it as the total charge flowing across a given cross section area of a wire or conductor in a given time interval. And in short, rate of flow of electric charge. Rate means always with respect to time. So now this statement we put it in an equation form. So current is what? Rate of flow of charge. That means charge by time. So current is represented by letter capital I, charge with capital Q, and time with small t. So instead of I is equal to Q by T, this is our formula or equation you can say, and instead of capital q we can put any. We got little while ago that total charge is equal to number of electrons into charge of one electron. So that way also we can write. Now what is the SI unit? SI unit, so I is equal to q by t. SI unit of q or charge is coulomb c. SI unit of time is second. So coulomb per second, that is also known as ampere. Ampere is represented by capital A. This is the SI unit of current. Now as we have defined 1 coulomb, similarly here also we will define 1 ampere of electric current. So numerically I is equal to q by t. So when I will become 1 ampere, when the charge will be 1 coulomb and the time will be 1 second. So 1 coulomb per second. So this in a statement form, if we write, the electric current is said to be 1 ampere if how much charge? 1 coulomb of charge will flow through a given cross sectional area in how much time? 1 second. In that case, we say that the current which is flowing through the conductor is 1 ampere. Next we come to the concept of electric potential. Now this you have to pay a bit attention, because this we consider a hypothetical situation. So suppose this is a unit positive charge. Unit means having a value of 1. There is a unit positive charge and there is a positively charged body, and let's say there is a point A inside that body. Now what is electric potential? First we need to understand what is the meaning of the term potential. Potential means capacity. So electric potential means the capacity of electricity. So how that capacity will develop? Now we know current is flow of charge. Now when charge will flow? When it will have a capacity to flow. So who will develop that capacity, or who will provide that capacity? It is electric potential. Okay, so first let us try to understand the theoretical meaning of electric potential. Suppose there is a unit positive charge and I am bringing it towards, so it is at infinity very far, so this body is exerting no force on that. Now slowly I catch this charge and I bring this charge towards this body. As I come nearer to this body, what will happen? This charged body, it is also positively charged. There is also a unit positive charge, unit, UNIT, single. So the more closer you bring this positive charge, this body will repel this charge. So actually this unit charge, the closer you bring, it will have a tendency to go away due to repulsion. But if you still want to bring it forward, suppose मैं इसको पास में ला के यहाँ आके ये मेरे हाथ से छूट जाता, this unit positive charge slips out of my hand, what will happen? Then it will rush back. So rushing back means it needs energy. Now from where that energy had come? Actually when I was bringing this unit charge towards this, so this body was repelling the unit charge, so I had to do some work against that repulsion. And you know that in class 9 you have got energy can neither be created nor be destroyed, it can only be changed, its form can be changed. So my energy which I am using to bring this charge to overcome the repulsion, that energy is getting stored in this particle. So the moment it comes nearer and nearer, more energy will get stored. So that is the concept of electric potential. So let us look at the theoretical definition, that electric potential at a given point, so suppose there is the given point A, is defined as the amount of work done. So you will have to do some work, is defined as the amount of work done in carrying or bringing a unit positive charge from where? From infinity to the given point. So infinity से आप ये point तक ये charge को लाने में जितना work done करोगे वही इस point में electric potential समझाया जाएगा. So that is the electric potential at that point. So let the work done be W. So the amount of work that we are doing in bringing the unit positive charge, let it be W. In carrying a unit positive charge, how much? What is the value? Let us take the value of the charge to be capital Q. From where? From infinity to the point A. So going by the definition, electric potential is what? Work done in carrying unit charge. So work done by charge. Okay. So electric potential is represented by letter V, work done by W and charge by Q. So V is equal to W by Q. So what is the SI unit? SI unit, work का SI unit होता है joule, charge का SI unit coulomb. So joule per coulomb, which is also known as volt, represented by capital V. So how do we define 1 volt? Now you see this is the only physical quantity where the letter representing the physical quantity, that is electric potential, this is also represented by V, and the SI unit of it, which is volt, that is also represented by V. So when we are defining 1 volt, so V is equal to W by Q. So electric potential 1 volt कब हम लोग कह सकते हैं? When the work done will be 1 joule divided by how much charge? 1 coulomb. So 1 volt is equal to 1 joule per coulomb. Now this thing we will write in a statement form. Therefore, the electric potential at a given point is said to be 1 volt. Okay, ये point में electric potential 1 volt समझाया जाएगा when we will do 1 joule of work in bringing 1 coulomb of charge from infinity to the given point. Suppose this charge is 1 coulomb और इसको infinity से इस point में लाने में I have done how much work? 1 joule of work. Then the electric potential at that point will be said to be 1 volt. Okay, so related with electric potential we have one more term which is called potential difference. Now this is a more practical thing to understand, which we use on our day-to-day life, this term. So potential difference is also known as voltage. Okay, now what is potential difference? First let us try to understand this. Suppose there is a unit positive charge which is kept at infinity. Now I am trying to bring this unit positive charge to a point A. So when I will try to bring this charge from infinity to point A, at this point a potential will develop, a capacity will develop, which is represented by VA. So VA is the potential at point A. Similarly, let's say there is another potential VB, there is another point B, and I am trying to bring this unit positive charge from infinity to point B. So the electric potential at this point will be VB. Okay, so this point is having a potential capacity, this point is having a potential capacity. So if we say potential difference, which is also called voltage, it is nothing but difference in the electric potential at 2 points. Now a more easy way to understand this, because you see any concept in electricity, if we try to make it more simpler, we always have to equate it or try to understand with the help of flow of water. Now suppose there are two vessels connected by a tube in between, and both the vessels, they have water at the same level, and there is a valve in between. Now when I will open the valve, water will neither, suppose there is A, there is B, water will neither flow from A to B nor it will flow from B to A, because both are at same level. Now if I keep one vessel on top and connect it with another vessel which is kept down, there is suppose vessel A and there is suppose vessel B, and if I open the valve in between, then water will flow from vessel A to vessel B. So there always needs to be a difference. Here it is a difference of potential energy. Here when we say electric current is flow of charge. So when charge will flow, when there will be a difference of energy. So इस जगह का एक अपना एनर्जी होता है या पोटेंशियल होता है, इलेक्ट्रिक एनर्जी और इलेक्ट्रिक पोटेंशियल, और इस जगह का अपना एक इलेक्ट्रिक पोटेंशियल होता है. तो wherever the electric potential is more, from there charges will flow towards another point where electric potential is less. Now you know घर में क्या होता है, when we say that there is a voltage drop, voltage घट जाता है, then we find कि fan धीमा हो गया या light का brightness नहीं रहा, it has become dim. So that means when there will be less potential, that means this difference will become less, the flow will also become less. So more will be the difference in the electric potential, more will be the flow of current. Lesser will be the difference of electric potential or voltage, lesser will be the flow of current. So potential difference of voltage can be defined theoretically as the difference of electric potential between any two given points. Suppose there is an electrical field, इसमें से कोई भी दो पॉइंट का इलेक्ट्रिक पोटेंशियल का जो डिफरेंस होगा, that is called potential difference of voltage. So therefore charges will flow from higher potential to lower potential. So what is the SI unit? Difference of potential means nothing but potential only. Suppose difference of your height is what? Height. So the SI unit is same as that of electric potential, which is volt. Now we will discuss about two apparatus. In your house you must have seen in the main switchboard or in the electric motor board, पानी का जो pump होता है उसका जो board होता है, or in stabilizer there are some devices or meter which looks like this. Okay, nowadays we have all digital, in our air conditioner and all, but there are some analog also. Here it is written V or it will be written A. If it is written V, that's voltmeter. If it is written A, that's ammeter. So ammeter is a device. The symbol of ammeter is like this, around A, plus sign and minus sign. So ammeter is a device which is used to measure current. So what will ammeter measure? It will measure the amount of current flowing through a circuit. And it is always connected in series. Series मतलब one coming after the another. Suppose this is the device. Device के साथ एक ही line में connected रहेगा. And how we connect an ammeter? The positive side of the ammeter will be connected towards the positive terminal of the circuit. Okay, and it is connected in series. We cannot connect it in parallel. Okay, now why I am telling you that? Current means what? Flow of current we can also equate with flow of water. Okay, अभी आपके लाइन में करंट फ्लो हो रहा है, पकड़ लीजिए पानी फ्लो हो रहा है, एंड यू वांट टू मेजर द अमाउंट ऑफ current which is flowing, or you want to measure the amount of water. So if you connect the ammeter in parallel, what will happen? Suppose I consider water to be flowing. पानी यहाँ पे आके दो लाइन है तो दो लाइन में पानी बढ़ जाएगा. So your ammeter will not be able to measure the total amount of what? Current flowing through the circuit, because the current will come here and it will get split in two lines if it is in parallel. We want to measure the total current. So this ammeter needs to be connected in series so that the total current flowing in the circuit can be measured. One more thing, हर एक device के अंदर एक resistance होता है. We'll get resistance in my next video. I'll discuss. So through the ammeter all the current should easily pass. Okay, so ammeter का जो internal resistance जब वो manufacture किया जाता है, when ammeter is manufactured, it is made sure that the internal resistance of the ammeter is kept low so that easily all the current can pass through the circuit. Next we come to voltmeter. So voltmeter, the symbol of voltmeter is like this, round inside V and plus and minus sign. So voltmeter is a device which is used to measure, क्या measure करेगा वो? Voltage या potential difference. Now difference is always measured across 2 points. Suppose एक wire है, इसके दोनों point, across the 2 points इसका difference क्या है? That we need to measure. Therefore we have to connect the voltmeter always in parallel, because across the 2 points we are measuring what is the difference. Okay, so because if you are connecting it in parallel, what will happen? In series, it will not get the 2 points across which you have to measure the potential difference. So this is not the correct way. Correct way is that you have to connect the voltmeter across the device across which you want to measure the potential difference. So, and the positive end of this voltmeter has to be kept towards the positive terminal, just like ammeter. So what will happen? This will be measuring the potential difference. Now what will happen to the current? As I told you before, current यहाँ पे आके दो भाग में बढ़ जाएगा. Now if the current gets divided, this device will not be able to work properly. Okay, so what happens जब voltmeter manufacture किया जाता है, when voltmeter is manufactured, the internal resistance of voltmeter is kept very high so that only minimum current can flow. ये voltmeter काम करने के लिए जितना current चाहिए बस उतना ही will flow through this, and most of the current will flow through the main line. Is that clear? So the internal resistance of the voltmeter is kept high so as to allow only minimum current to flow through it, so that maximum current can flow through the device. Is that clear? So these are the concepts of electric charge, electric current, potential, electric potential and potential difference. What is an ammeter and what is a voltmeter? In my next video I will be discussing about Ohm's law, resistance and resistivity. Thank you.